All right, y'all, today we're going to be talking about systems of two equations. Now, this is a skill that you should have done before in Algebra 1, so it should be familiar. As well, we've done a little bit like we did back in quadratics with our writing and solving equations, but we're going to go a little bit deeper in this unit. We're going to solve systems of 2, 3, inequalities, linear and quadratic. We're going to really go a lot further than you did in Algebra 1. So to start this off for our notes today, I want you to go ahead and do this warm-up, which fair is fair, about 2 different taxi rides you could take to the airport. Try to complete as much as you can. Write a system of 2 linear equations for each of the companies. Graph that system. If you can by hand, if you need a little help, you can use your calculator. Then solve that system of linear equations algebraically with any method that you feel comfortable with. And then draw some conclusions there in number 4 and number 5. So go ahead and pause me now, and I'll go over this here in just a moment once you're ready. All right, let's talk about our 2 taxis. So we have 2 local taxi companies. Our Friendly's cab company charges $2.60 plus 20 cents per 1/6 of a mile driven, and Anderson Taxi Incorporated charges $5 plus 10 cents per 1/6 of a mile driven. Okay, so we can write 2 different equations that per mile is definitely going to be our slope for each of these linear equations. That initial upfront cost, 260 and 5, is going to be that y-intercept. So for Friendly's, we get y is equal to 0.2x plus 2.6. And then for Anderson's, we get y is equal to 0.1x plus 5. Okay, and then we can graph both of those on our graph. Anderson starting at 5 and then going up by 0.1 for each 1/6 miles. Okay, and then our Friendly starting at 2.6 and then going up 0.2 for each. So to kind of help read this graph a little bit, I'm going up by $1 in cost every 10 miles, which is the same as 0.1, 10 cents every mile, and then 20 cents every mile, or $2 every 10 miles. Makes it a little bit easier to kind of see. Now, looking at this graph, it looks like we have an intersection point. If I was to estimate, it's probably about somewhere in the 24 to, it looks like 7.5 maybe. I did get, of course, 7.4 because I've done this before, but you might have gotten something in the 24 to 7.5 kind of range. Okay. And then we can solve that system of linear equations in any way. We could do elimination, we could do substitution. Technically, we have a graph, so we could do graphically as well. If you could really tell, but because of those decimals, graphically might not be our best option. Since both of these equations are equal to y, I went ahead and did substitution. I set one of those equations in for y and the other equation. So I get 0.1x plus 5 is equal to 0.2x plus 2.6. Okay, and then I moved my 2.6 over to the other side. So 5 minus 2.6 gives us 2.4. And my 0.1x over to the other side. So that gives me 0.1x. And then dividing both sides by 0.1, 2.4 divided by 0.1, which is the same as multiplying by 10, gives me an x value of 24. And then once I have that x value of 24, I can plug it into either equation. I chose to plug it into my y equals 0.1x plus 5 equation. So 0.1 times 24 plus 5 is equal to 2.4 plus 5, which gives us 7.4. Okay, now what does the solution actually mean in terms of our situation? Well, as we can see, looking at our graph, that's our cost of both of our taxis over time. And so that intersection point there at 24 miles, that's when both of our taxis are going to cost the exact same amount. So after 24 miles, despite the fact that Anderson charges a much higher upfront fee, Anderson's and Friendly's are going to start costing the same. And then instead of Anderson's costing more and Friendly's costing less, after that 24-mile point, Friendly's is going to start costing more and Anderson's is going to start costing less. Okay, and then last but not least, suppose that Anderson Taxi Incorporated decides to increase its fare to 20 cents per 1/6 mile driven, write a new system of equations to reflect the increased fare. And so we have y is equal to 0.2x plus 5 and y is equal to 0.2x plus 2.6. So if they now have that same cost per mile of 0.2x and 0.2x, if they're both increasing at the same cost per mile, then they're actually never going to intersect because now we actually end up having two parallel lines that are never going to find that intersection point. Because think about it, if Anderson is charging 20 cents per mile and Friendly's is charging 20 cents per mile, then they're always going to keep increasing by the same amount per mile. So it's always going to cost more to take Anderson instead of Friendly's because Anderson charges that extra $2.40 for that upfront cost. Okay, and we could have a couple of different situations. So we have our parallel, same slope. That's our situation we have here with Anderson's and Friendly's. We could have the exact same line. So if they cost the same initial amount and they had the same rate, then they'd be the exact same line, which technically means it would always cost the same, which means it has infinite solutions. And then last but not least, which is what we had before they had the same cost, we have those intersection points, not necessarily perpendicular, no, because you see parallel, you might think perpendicular, but it's just any two slopes that are going to cause the lines to eventually intersect, which means we should have that single solution. Okay, we're going to pivot just a little bit. We're going to do some graphing. Okay, so we're going to dive a little deeper into each of our methods, our graphing, our elimination, and our substitution methods today. So first and foremost is our graphing. I think this is the one that's going to be most straightforward for a lot of people. So with our graphing, we do want to have both of our equations in y equals, just like we had in our warm-up. So here we have y equals 3f x plus 2 and y equals x minus 3. So if both of our equations are in y equals form, then we can just take our lines and we can go ahead and graph them. So I'm going to graph my y equals 3/2 x plus 2 first. So a y-intercept of 2, and then a slope of up 3 and over 2. And I can do the same thing in the opposite direction. And then I can go ahead and graph that first line. And then same thing for my second line. We have negative x minus 3, which negative x is the same as negative 1. So I'm going to go here to negative 3. And then for each of my points, I'm just going down by 1 and to the right by 1 for that slope of negative 1, which once you see the pattern, you can start plotting your points pretty quickly. Same thing in the other direction. And then, of course, once you have enough points that you feel comfortable, so you don't have to have all of them, it's just once you kind of understand, you can go ahead and pop on that second line. Okay? And if we've done our job correctly, we should have those two lines. And if we're going to have that first situation of intersection, we're going to have that single solution. So we can see pretty clearly right here that we do have that intersection point of negative 2 comma negative 1. So graphically is fairly straightforward. It's going to be as long as both of those equations are y equals, it's going to be our most straightforward of our methods. So I want you to go ahead and do number 2 on your own without my help. Both of those equations are in y equals. Okay, so go ahead and pause the video and try number 2. All right, y'all, and for number 2, we have that y equals 1/2 x plus 3, so plus 3 and then up and over, up by 1 and over by 2. Up by 1 and over by 2. And then for our second line, y equals negative 2x minus 12. So minus 12 is a little bit off. Okay, probably down here, but we can, of course, backtrack. So to the left by 1 and up by 2 and backwards all the way until we do find that intersection point right here of negative 6 comma 0. Okay, so relatively straightforward. Now, let's say that I want to do these graphically. I know these are relatively straightforward, but even like the one in our warm-up, that one was a little harder to do by hand. So if I wanted to do either of these graphically, and I'm going to use this equation for number 2, I can go to my TI-84, okay? And the first thing I want to do is I want to go ahead and hit my y equals right here. So in my y equals, I'm going to go ahead and type in my first equation. So alpha y equals to get my nice fraction. And I have 1 over 2 and then x. And then plus 3. And my second equation, negative 2x minus 12. Okay, and once I have both of my equations correctly graphed, I can go ahead and graph them. Your calculator should probably do it fairly quickly. And of course, we can see that same intersection point, but let's say we weren't quite confident, we weren't quite sure if that is the correct point, then we can, of course, actually solve for this. We can go to this calculate menu, which see how the calculator is in blue. We're going to hit second and then that calculate button, which will take us to this calculate menu. And we want this fifth option right here, intersect. And when you hit that fifth option, intersect, you're going to see it's going to ask for the first curve. And notice how our cursor is over here. We want to get it as close as possible to our intersection point. We're going to arrow over. This might take quite a bit. You can also hold it down and we'll go there. So notice I don't have to be perfectly on it. I just want to be close. So I'm going to hit enter. And then see how it changes red? It's now on the red line. So I could move this up and down, but it's going to try and stay relatively close to your first cursor. So you can hit enter again. And then it's going to ask to guess, and you do want it to guess. Sounds like it's making a guess, but your calculator is going to give you that exact point, which would be that x equals negative 6, y equals 0. So relatively straightforward with the calculator, just got to remember a couple of those functions. And this is usually for ones that would be a little bit difficult for us to graph, but I still expected you to maybe solve this graphically. They're both in y equals. Okay, so let's go back over to our notes. Let's look at a graphical one that's maybe a little bit more different. So with this one, we have 5x minus 4y equals 24, and 2x plus y is equal to 7. So first thing that we notice right off the bat is that neither of these are in y equals form. Now, I would argue that maybe a different solving method would be better for this one, but let's say we wanted to still use graphing. We can get both of these to be able to graph. We're just going to want to solve them for y first. So if you can solve these for y, go ahead and pause me, and you can go ahead and do this one on your own. If you just want to watch anyways, go ahead and watch me solve each of these. So let's take that first equation, 5x minus 4y is equal to 24. And let's go ahead and solve that one for our y equals. So 5x minus 4y is equal to 24. So I want to isolate that y. So minus 5x and minus 5x. So we get negative 4y is equal to negative 5x plus 24. And then on both sides, I'm going to divide by 4. Sorry, negative 4, which of course gives us y is equal to positive 5/4 x and then minus 6, because everything's getting divided by that 4. Negative 4, sorry. Okay, and then my second equation, 2x plus y is equal to 7. I will go ahead and do the same thing for that one. So 2x plus y is equal to 7. Same thing, I want to get that y by itself, so I'm going to move that x term. So we get y is equal to negative 2x plus 7. And this one's even easier. I don't have anything in front of my y, so I can go ahead and call that one done. So y equals negative 2x plus 7, and y equals negative 5/4 x minus 6. Okay, now all I got to do from there is go ahead and graph it, which I already have done. Same thing as before, plot that y-intercept, do that slope, and we do get that point, 4, negative 1. Okay, so the only hard extra step on number 3 is, of course, if I want to do graphing, I just got to get them both into y equals, and then I can still solve them. Okay, so let's shift again, and we're going to talk about a slightly new solving method. We're going to talk about solving by substitution. Okay, and so for each of these, we're going to write y equals mx plus b equation, and then once we write that equation, we're going to use our substitution method to solve these. So let's look at our first table. We have x is equal to 0, 2, and 4, and y is equal to negative 30, negative 26, and negative 22. So to be able to write a y equals mx plus b equation, two things I need my slope and I need my y-intercept. Okay, so right off the bat, I have my y-intercept. It's always going to be when x is equal to 0, which I do have for this point right here, 0, negative 30. Second thing I want is I want my slope. Slope is change in y over change in x. So from 0 to 2, I'm doing plus 2. From 2 to 4, I'm doing plus 2 in the x direction. In the y direction, negative 30 to negative 26 is plus 4. Negative 26 to negative 22 is also plus 4. So in this case, slope would be equal to 4 over 2, which is just equal to 2. And then for my y-intercept, my b, it would be equal to that negative 30. So of course, I have everything I need to write this in slope-intercept form. So my equation in this case would be y is equal to 2x minus 30. All right, and then likewise over here on my second equation, for my x values, from negative 2 to 0, we are adding by 2. From 0 to 2, we are adding by 2. In my y direction, from 5 to 3, we are subtracting by 2. And from 3 to 1, we are subtracting by 2. And just to check again, 0 to 3, when x is equal to 0, that is our y-intercept. So in this case, our y-intercept would be equal to 3, and our slope would be equal to negative 2 over 2, which would be equal to negative 1. So our equation in this case is negative 1x plus 3. Okay, so once I have both of my equations written, I can now do my substitution method. Notice how both of these are already y equals. That means I can just plug one of these equations in for y and the other one. So from here, I can say 2x minus 30 is equal to negative x plus 3. So all I've done is I've replaced y in my second equation with what I know y to be equal to with my first equation. So from here, I can just go ahead and solve for x. So add by x. That's going to give me 3x minus 30 is equal to 3. Then add 30, and we get 3x is equal to 33. Okay, taking that 3x is equal to 33, last thing I need to do to solve for x is divide both sides by 3, and we do get that x is equal to 11. Okay, once I know what x is equal to, I can plug that into either of my two equations. I'm going to plug it into the second equation because I'm not going to have to multiply it by anything. So y is equal to negative 11 plus 3. Negative 11 plus 3 would, of course, be equal to negative 8. So my final solution would be 11 comma negative 8. Okay, and that is our substitution method. So once we have our two equations, we can set them equal to each other if they're both y equals, or I can plug in for any variable. So if I have an x equals equation instead, I could plug in for x. Then I'm just solving for the variable that I have left behind. Okay, so go ahead and apply that same idea to number 5 and pause me for right now, and then you can watch me go over it here in just a moment. All right, on number 5, we have our table on the left where our x values are increasing by 2 and our y values are increasing by 2. So 2 over 2 for our slope. We can see our x is 0, our y is 5, so y-intercept of 5, which gives us the equation y is equal to x plus 5. Our table over on the right, our x values are once again increasing by 2. Our y values this time, though, are decreasing by 2, so negative 2 over 2 is going to give us a slope of negative 1, and then a y-intercept of negative 2, where x is equal to 0. So negative x minus 2. So we have our two equations, y equals x plus 5, and y equals negative x minus 2. Once again, I can set those equal to each other. We have x plus 5 is equal to negative x minus 2. Adding x to both sides and subtracting 5 from both sides gives me that 2x is equal to negative 7. From there, I can divide both sides by 2, and I get the x value of negative 7/2. Now, I know fractions are gross. We never love fractions, but it's okay. We can still work with them. So plugging in to my first equation, y equals x plus 5, y is equal to negative 7/2 plus 5. Changing that 5 into a fraction I can add to negative 7/2. That would be 10/2 by multiplying 5 over 1 by 2 on the top and the bottom. So negative 7/2 plus 10/2 would give me 3/2, and we get the solution point -7/2, 3/2. Okay, so substitution also fairly straightforward. We're just plugging in for one of our variables as long as one of the equations is solved for a variable. So either solved for y or solved for x. The very last method we're going to talk about is our elimination method, which this is the one that we've kind of talked a little bit about before, but we're going to go into a little bit more detail here today. So on number 6, Liam's bookstore sold 40 notebooks and 20 newspapers for a total of $260. A day later, the bookstore had sold 8 notebooks and 2 newspapers at the same prices for a total of $46. How much does a notebook and newspaper cost at Liam's bookstore? So just like our last one, we need to write our equations here first. This is not going to be in slope-intercept form because we have 2 different variables. So this is actually going to be in standard form, which, just in case you forgot, standard form is ax plus by equals c. That c usually being a total, and then that a and that b being an amount or a cost of our 2 different variables. So we have notebooks and newspapers, so we can go ahead and say x is equal to notebooks and y is equal to newspapers. And so our first equation, 40 and 20, so that would be 40x plus 20y, and that's going to be equal to the total, which in this case was 260. Right? And then our second equation is on day 2, they sold 8 notebooks and 2 newspapers. So 8x plus 2y, and that was equal to 46. All right, so we have our 2 systems of equations, but for elimination to work, we have to have opposite but equal coefficients. So opposite signs, but that same number. So right now we have 40x and we have 8x, we have 20y and we have 2y. So none of our coefficients are the same, and we don't have any opposite coefficients. So I'm going to have to multiply one of these equations by a value. It doesn't matter what I multiply by. Technically, you can also multiply by a fraction or divide an equation. I find it usually simpler to just multiply. The dividing can get kind of complicated. Okay, so I can either multiply the second equation by -5, which would get everything, this 40 and -40, or I can multiply that second equation by -10, which would give us 20 and -20. I'm going to do -10 because I think it's a bit easier to multiply everything by tens. So let's multiply that second equation by -10. So multiplying everything by -10, that gives us -80x minus 20y is equal to -460. Okay, and then I still have my other equation of 40x plus 20y is equal to positive 260. And then from here, I can take my 2 equations and I can add them together. So -80 plus 40 is going to give me -40x. -20y plus 20y, that's going to cancel out. And -460 plus 260, that is going to give me -200. So that gives me this simplified equation of -40x is equal to -200. And then dividing both sides by -40, that gives me x is equal to, let's see, 0, 0, 20 divided by 4 would of course equal 5. And this is in dollars amount, so that means x is equal to $5. If x is equal to $5, I can pick either equation to plug into. I'm going to do that second one because my numbers are a little bit smaller. So 8 parentheses 5 plus 2y is equal to 46. And once again, if I did everything correctly for my elimination method, I should only have a single variable once I plug in. So just to kind of recap, when I did my elimination, I eliminated my variable y, so I only had the variable of x. Once I have x, I've plugged back in so that I only have the variable y that I can solve for. So 8 times 5 is going to be 40, plus 2y is equal to 46. Then solving for y a bit, we can subtract both sides by 40. We get 2y is equal to 46, dividing both sides by 2. And we get, not 46, sorry. 2y is equal to 6. And then dividing both sides by 2, we get y is equal to $3. So our point that we get is 5, 3. But of course, for our exact question, we don't necessarily care about the point. We do care about the actual cost of each one. So our notebooks was X. So notebooks are $5. And our newspapers were Y. So newspapers are $3. All right, y'all. And it's really simple as that when we're solving using elimination. So just like before, sometimes we might need to write our equations, which we can write equations in slope-intercept. We can write them in standard form. And then sometimes we can use elimination, we can use substitution, or we could even use graphing. It really just depends on the situation, which one might be the best setup for each. It doesn't matter which one you use. Okay, so I want you to go ahead and solve out number 7. You can do it with me, or you can go ahead and pause and try number 7 on your own. All right, last but not least, number 7, we have a Parisian cafe that has cups of coffee, which we can make our x variable, and croissants, which we can make our y variable. So it says you can buy a cup of coffee and a croissant for €530. So x plus y equals 530. And then our friend gets 2 cups of coffees and 3 croissants, and that costs €1360. So x plus y equals 530, and 2x plus 3y is equal to 1360. Okay. And then I can multiply that first equation by 2, or you can think of it as multiplying it by -2, whichever works for you. So we get 2x plus 2y is equal to 1060, and then I'm going to subtract the 2 equations. So you can multiply by -2 and add the 2 equations, or you can multiply by 2 and then subtract the 2 equations. Either way is going to work. So 2x minus 2x, that's going to cancel out. 3y minus 2y is going to give us 1y. And then 1360 minus 1060 does give us y is equal to 3. So that's croissants are going to be equal to that €3. So once I know that, I can plug back into my original equation. I'm going to use that first one because it's just single variables. So x plus 3, I'm plugging in for y, is equal to 530, subtracting 3 on both sides, and we get x is equal to €230. So coffee is equal to €230, and croissants are equals to €3. And y'all, that is systems of 2 equations, relatively straightforward. When you're doing them, you can use graphing, substitution, or elimination. I'm never going to designate a specific skill that you have to use. Just use whichever one that's going to be best for the situation or most comfortable for you.